Jupiter, the largest planet in the solar system. Jupiter's signature stripes and swirls are cold, windy clouds of ammonia and water, floating in an atmosphere of hydrogen and helium. The dark orange stripes, called belts, and the lighter bands, called zones, flow east and west in opposite directions. These patterns create the planet's distinctive appearance. One of the most iconic features is the Great Red Spot, a giant storm bigger than Earth that has raged for hundreds of years. Jupiter, the king of planets, was named after the king of the gods in Roman mythology. Most of its moons are also named for mythological characters associated with Jupiter or his Greek counterpart, Zeus. Jupiter's massive size and distinctive features make it a fascinating subject of study. The planet's environment is extreme, with temperatures, pressures, and materials that make it unlikely to support life as we know it. However, some of Jupiter's moons, particularly Europa, are considered potential habitats for life due to the presence of vast oceans beneath their icy crusts. With a radius of 43,440, 7 miles 69 to 911 kilometers, Jupiter is 11 times wider than Earth. If Earth were the size of a grape, Jupiter would be about as big as a basketball. It orbits the Sun at an average distance of 484 million miles 778 million kilometers, which is 5.2 astronomical units away from the Sun. This distance means that sunlight takes 43 minutes to travel from the Sun to Jupiter. Jupiter has the shortest day in the solar system, with one day lasting only about 10 hours. A year on Jupiter, or the time it takes to orbit the Sun, is about 12 Earth years for 333 Earth days. The planet's equator is tilted by just 3 degrees relative to its orbital path, resulting in minimal seasonal changes. Jupiter is a mini solar system in itself, with 95 moons officially recognized by the International Astronomical Union. The 4 largest moons Io, Europa, Ganymede, and Callisto were first observed by Galileo Galilei in 1610 and are known as the Galilean satellites. Io is the most volcanically active body in the solar system, while Ganymede is the largest moon, even bigger than Mercury. Callisto's surface shows signs of some degree of activity, and Europa is believed to have a subsurface ocean that could potentially harbor life. Discovered in 1979 by NASA's Voyager 1 spacecraft, Jupiter's rings were a surprising find. These rings are composed of small, dark particles and are difficult to see except when backlit by the Sun. Data from the Galileo spacecraft indicate that Jupiter's ring system may be formed by dust kicked up as interplanetary meteoroids smash into the planet's small innermost moons. Jupiter took shape along with the rest of the solar system about 4.5 billion years ago. Gravity pulled swirling gas and dust together to form this gas giant, which took most of the mass left over after the formation of the Sun. Jupiter has the same ingredients as a star, but did not grow massive enough to ignite. About 4 billion years ago, Jupiter settled into its current position as the 5th planet from the Sun. The composition of Jupiter is similar to that of the Sun, mostly hydrogen and helium. Deep in the atmosphere, pressure and temperature increase, compressing the hydrogen gas into a liquid. This creates the largest ocean in the solar system, an ocean of liquid hydrogen. At great depths, the pressure becomes so intense that electrons are squeezed off the hydrogen atoms, making the liquid electrically conducting like metal. Jupiter's fast rotation drives electrical currents in this region, generating the planet's powerful magnetic field. As a gas giant, Jupiter doesn't have a true surface. It is mostly swirling gases and liquids, and a spacecraft would have nowhere to land. The extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft attempting to enter the planet. Jupiter's atmosphere is a tapestry of colorful stripes and spots, created by the cloud bands and cyclonic storms that dot the planet. The gas planet likely has 3 distinct cloud layers in its skies, which span about 44 miles 71 kilometers in total. The top cloud layer is probably made of ammonia ice, the middle layer of ammonium hydrosulfide crystals, and the innermost layer of water ice and vapor. The vivid colors seen in Jupiter's thick bands are thought to be plumes of sulfur and phosphorus-containing gases rising from the planet's warmer interior. Jupiter's fast rotation creates strong jet streams, separating its clouds into dark belts and bright zones. Without a solid surface to slow them down, Jupiter's spots can persist for many years. The Great Red Spot, a swirling oval of clouds twice as wide as Earth, has been observed for more than 300 years. Data from NASA's Juno probe, released in October 2021, provides a fuller picture of what's going on below Jupiter's clouds. The cyclones are warmer on top with lower atmospheric densities, and colder at the bottom with higher densities. Anticyclones, which rotate in the opposite direction, are colder at the top, but warmer at the bottom. These storms are far taller than expected, with some extending 60 miles 100 kilometers below the cloud tops and others, including the Great Red Spot, extending over 200 miles 350 kilometers. Jupiter's belts and zones, the white and reddish bands of clouds, are separated by strong east-west winds. Juno discovered that these winds reach depths of about 2,000 miles 200 kilometers. Researchers are still trying to solve the mystery of how these jet streams form. Data collected by Juno during multiple passes reveal that the atmosphere's ammonia gas travels up and down in remarkable alignment with the observed jet streams. Juno also discovered polygonal arrangements of giant cyclonic storms at both of Jupiter's poles, 8 in an octagonal pattern in the north and 5 in a pentagonal pattern in the south. These atmospheric phenomena are extremely resilient, remaining in the same location over time. Juno data indicates that, like hurricanes on Earth, these cyclones want to move poleward, but are pushed back by cyclones located at the center of each pole. Jupiter's magnetosphere is the region of space influenced by its powerful magnetic field. This field balloons 600,000 to 2 million miles 1 to 3 million kilometers toward the Sun and tapers into a tadpole-shaped tail, extending more than 600 million miles 1 billion kilometers behind Jupiter. As far as Saturn's orbit, Jupiter's magnetic field is 16 to 54 times as powerful as Earth's, trapping swarms of charged particles and accelerating them to high energies, creating intense radiation that bombards the innermost moons and can damage spacecraft. Jupiter's magnetic field also causes some of the solar system's most spectacular aurorae at the planet's poles. The Jovian auroras are produced by the interaction of the magnetic field with particles from the solar wind and volcanic material from Io. These interactions create brilliant displays of light in the planet's upper atmosphere. Jupiter has played a crucial role in shaping our solar system. Its immense gravity has influenced the orbits of other planets and helped clear the early solar system of debris. Jupiter's gravity can also act as a shield. Stay tuned for more exciting space discoveries on InfoBurst.